Hello everyone, this is Drew here, and we're going to look at page 28 from your FOSS book. The article is called Three Phases of Matter. We're going to sort of do a read along and think about and discuss some things here. So let's go ahead and take a look. Again, I'm on page 28. Three phases of matter. Penguins live among all three phases of matter: solid, liquid, and gas. We see some penguins down here. It says the penguins are surrounded by water in its three phases: solid ice, liquid water, and water vapor gas. Have you ever experienced all three at the same time and place? Something to consider. The solid ice is a secure place where for these birds to stand. The liquid water is where they swim to find food, and the invisible gas, air, is blowing all around them. Ice, water, and air have different properties. Solid ice has a definite size, volume, and shape. In other words, the size and shape do not change. That is characteristic of all solid substances. Okay? So solids have a definite size or volume. Let's move on to page 29. Liquid water has definite volume, but its shape changes. It forms waves, crashes up on the shore, and flows back to the sea. The volume of a liquid is always the same, but its shape depends on where it is. That is a characteristic of all liquid substances. All liquid substances have the same shape, but the volume rather is always the same, but the shape depends on where it is. Air does not have a definite volume or shape. Air fills in around everything and can take any shape. The ability to change volume and shape is a characteristic of all gaseous substances. So all gases have the ability to change volume and shape. Why is ice solid? Why is water liquid and air gas? The phase of a substance depends on the relationship between the particles of that substance. In solid ice, the particles are stuck together. They cannot move around because forces attract and hold the particles to each other. These attractive forces are called bonds. They glue particles together. When particles cannot move, the substance cannot change size or shape. In liquid water, bonds hold particles close to each other, but they are not stuck together. The particles move over and around each other. That allows water to flow. Particles in liquid are packed close together, so the volume always stays the same. But because particles can move, the shape of the liquid can change. Liquids can take shape of their containers. So let's take a look at this. It says the properties of three phases: solids, liquids, gases. Solids have a definite volume and shape and sit at the bottom of their container. So you can see the ice here, it's at the bottom, and when the vial's tilted, you can see that the ice cube starts to slide, and then when it's on its side, you can also see that the ice moves. Let me move myself over to the other side here. Here are some liquids. Here's the liquid laying flat. Then you can see how the liquid has the same volume, but it's changing to the shape of the container, and then it's laying again when the vial is laying flat. So liquids have a definite volume, but their shape changes with the container. And then gases, as we said before, have no definite volume or shape, and they always fill the container. So it doesn't look like much is happening when we tilt the vial from right side up to sideways. Let's turn the page. In gas, particles fly around in space as individuals. Particles have a lot of space between them. Because they are not bonded, They spread out in a container. Gases have no definite volume or shape. Gases fill any container they're put into. Okay, so this is maybe the third time we've heard this, so it's probably important. Okay, applying force to matter. Applying force to matter. Let's look at these three samples of matter. One sample is solid, one is liquid, and one is gas. Each sample is made up of 39 particles. Each is in an identical container. This is how the particles would be organized in three samples. A syringe is a good tool for applying force to samples of matter. We can use a syringe to see what happens when the force is applied to a solid, liquid, and a gas. So let's take a look at these. Three samples of matter: solid, liquid, gas. You can see the particles for the solid are very organized. They're nice and tidy in nice, neat rows. Liquids, they're close together, but they're kind of every which way. You can see they're not in nice rows. And then gases are all over the place. Now, when they push the plunger down, the particles aren't really moving anywhere. There's no way to compress them. They're already tight for the solid. And with the liquid, they move a little bit, but not much. And with the gas, they push down and tighten up even more, but there's still resistance there. The particles of a solid are touching and bonded tightly. The particles of a liquid are touching, but they can move. The particles of gas have a lot of space between them. And it also says, this liquid has bubbles of gas floating through it. The liquid and gas have different properties. So you can see that in the background, it looks like what? Maybe Coca-Cola back here? So there's some gas within that. All right, let's go over to this part of the page. Solids and liquids are not very interesting in a closed syringe. They cannot be forced into a smaller shape because the particles are already in contact with one another. But there's a lot of space between gas particles. Gas can be compressed. The particles of compressed gas are forced closer together, but there is a limit to how much gas can be compressed. At first, it is easy to push the plunger down. The air inside the syringe feels spongy, but the further down you push the plunger, the harder the air feels. Why is that? The air particles are flying around very fast inside the syringe. When they crash into the plunger and the walls of the syringe, they apply force. Okay, so that's pointing at number 1 down here. When the plunger pushes gas into smaller space, it pushes the particles much closer together. This results in more particles hitting the plunger every second. The particles pushing on the plunger tip make it harder and harder to push the plunger. So you can see that in number 2. So let's take a closer look at this diagram. Notice there's air outside and there's air inside. Air particles apply force to everything they hit. The force pushing down the plunger, that's the blue arrows over here. The force pushing down the plunger pushes the air particles in the syringe closer together. So again, the outside, they're still spaced out, but look at inside, they're closer together. Let's go ahead and take a look at this last page, a bubble in a syringe. A plastic bubble filled with air crumples up when you compress the air around it. Can you figure out why? When air compresses, the air particles hit everything with more force. They hit the plunger, the walls of the syringe, and the plastic surrounding the air in the bubble. The plastic pushes the air inside the bubble. The air inside the bubble compresses just like the air outside the bubble. The number of air particles inside the bubble stays the same, but the space occupied by those particles, the volume, is smaller. The plastic bubble crumples because its air volume is smaller. So let's take a look here. Here is sort of like a bubble wrap bubble, and there's air inside it, and there's air around it, and it's inside the syringe. Then, when they push the syringe down, the air is compressed and in the syringe and in the air bubbles, in the plastic popping bubble there, the packing bubble. So everything's tightening up here, and so it looks like the the bubble wrap bubble is getting much smaller. And then of course if you pull the plunger back out, the bubble will expand. And I suppose if you pull it out far enough, it will pop. So we have some think questions here. What crumples a plastic bubble in a syringe when you apply force to the plunger? How is the motion of particles in a solid, liquid, and gas different? Why does air feel hard when you push on the plunger of a closed syringe? So why does it feel hard to press that in? Okay, so think about that. But the main thing we need to think about is, what is the relationship between particles of matter? Can you describe a solid, a liquid, and a gas, and how their particles are related, or are they different?